Today mainly we'll discuss about the transformer that is in us. So what is transformer? It is a device which is the voltage or two. In this will have the winding. Okay, this one is known as primary winding and this one is known as secondary winding. Okay, the primary winding, the supply is there, and in the secondary winding load is there. Like, have you seen transformer? Tell me, like nearby to your house or nearby to your society or nearby to your hostel,
Mm,
there
well,
must be any transformer nearby to your hostel only.
yeah, I think I've seen those machines, the square kind of rectangular.
So that is transformer, and one supply we are getting side, another supply, another side is connected to our load. Load means which we are consuming, that is fan, AC, bulb, that is load. Okay, here we'll get V1 voltage, and here the output voltage is V. Here the number of turns is N1, here the number of turns is N2, here the current flow is I1, here the current flow is I2, right? And
Yeah,
due to the current, there is a flux generated in the, and that flux is by phi, correct? That
yeah,
flux is denoted by phi. Here, EMF will induce. How the EMF will induce? According to the Faraday's law of electromagnetic. Okay? What does Faraday's law states that? He states that if there is EMF, EMF formula is minus phi by dt.
yeah,
He simply says that there is a change in flux with respect to time. If there is change in flux with respect to time, then only in that case EMF will induce. Okay. If there
yeah,
is no flux with respect to time, then in that case EMF will not induce. So now the question arises how the flux will change. Flux will mainly depend on current, right? Flux will depend on current. If current changes, flux will, and current will change only in case of AC, right?
yeah.
Flux will change only in case of, and flux will not change in case of DC, right? So that's why we always say that transformer always works on AC. Okay, that's why we always say that transformer works in AC,
Okay.
never on DC. Because in AC current will there is a change in the current, then in that case flux will change, and if flux will change, then EMF will induce. So if in the primary winding we are giving supply V1, and in primary winding only EMF is that E1, and that is technically known as self-induced EMF. Okay, that
Yeah,
is technically known as self-induced. And if we are giving voltage in the primary side, but total EMF is side, that is as actually, okay, that is understood.
yeah.
So basically, inside we output on the second side, that correct.
Yeah,
If N2 is N1 means number of turns, finding the number of turns, that case 2 is greater than E1, N1 is greater than N, that case 1 would then correct.
yeah,
For this we have one formula, that is by N by V is equal to E by E I1 equal to K, where K got the transform ratio. Okay, K is the ratio. Understood?
okay.
So Like now the question arises, EMF is right one and depend on which factor. So we'll have E1 is equal to 0.44 N1 phi m, that will be 1 equal to 0.4 F phi m. Okay, yeah. So
Yeah.
maybe they'll give you numerical base, not give, because in B it ask you
Okay.
the transform. Okay, but if they'll give you the numerical, that would be formulas only.
What
One
is M?
formula and this
What is M? E N1 F
F
5.
phi m. Phi m is maximum. Phi is basically flux and m stands for maximum. Okay?
Oh, okay. Yeah.
Now sometime they'll give you the dash 2. That means this one is HV and this H. Okay, then they will, maybe they'll flux of 20 milliweber. Maximum flux means phi m. Okay, or maybe flux only. And maybe they ask you calculate a number of turns n1 and frequency 1. So we'll have formula 1 is equal to 0.41 phi m, right? E1 is even is the EMF in the same only. That would be 4.44 N1 we calculate phi m is maximum flux, that per minus 3. Okay, so
I'm
from here N1. Next topic is, that is transformer. I told. Next is types. Like how many types? As I told, types transform another down transformer. In the step up transformer in voltage, or we can N2 N1, right? If there is a step down transformer, just become N2, correct? So
yeah.
basically we'll have two types of transformer, step up and, got it?
Yeah.
Next topic is the they are asking application. For transformer, DC induction, ask the principal application. Okay.
Okay.
So now see, basically start with the right. One is the AC machine, right? And one is, so instead of machine can be generator or motor, correct?
Yeah.
Or a category. One is the motor and another the synchronous. Synchronous motor is not mentioned in FE earlier. There is induction motor. Next we'll
Okay.
have, we are getting DC output or will give DC supply, then it's motor. If we'll get the AC, then it's a AC. Okay.
Yeah.
So what is the difference in basically induction? So we can change this according to our requirement, and for DC also we can the speed. But for synchronous, speed must be constant. Okay.
Okay.
Now then let's start with the DC motor. How it works? The motor is basically it converts electrical energy to mechanical energy. Correct?
Yeah.
So let's have, suppose as you have studied in class also, every have magnetic or no.
Yeah.
So in magnetic poles may be temporary power. So I'm taking over here permanent magnet, and in there must be coil. Yes or no?
Yeah.
So in coil, as you know, converts electrical energy, mechanical energy. That means they are providing electrical energy. Correct?
Yeah.
They are providing electrical energy. Now see, if there is current from wire, then in that case, flux. Yes or no?
Yeah.
And that means magnetic flux may be magnetic generated. So no,
Yeah.
as you can see that there is a north south pole magnetic lines that must flow between south. Correct? Because
Yeah.
magnetic lines will always move south. Correct? There is a magnetic lines south and there is a current in the wire that also produces magnetic field. Correct?
Yeah.
But if you see it from the above side, there magnetic lines cuts like this because current is direction, right? But if downward side, then current will here. Correct?
Yeah.
Because current is moving like this, then the magnetic field same direction, right?
Yeah.
So as you can see that there are two magnetic. One is the magnet, right? And another one is the coil. Correct?
Yeah.
So if you see from the downward side, magnetic field lines of the coil and magnetic field lines of the magnet, they both are in the same direction. Both are like this, right?
At the bottom.
At the bottom.
Yeah.
Then that means will add with each other.
Yeah.
But if we'll see from the above side, that coil magnetic field lines are moving like this, right? And magnet move from like this. That is opposite, right?
Yeah.
From the bottom side, that would be, and if you the side, then that would be opposite, correct?
Yeah. Yeah.
So in this case, suppose it's north pole and this south pole. If the magnetic field lines are in the same direction, then that will add with it. In this case, add with each other. If you are in the opposite side, then that will cancel out with it. Correct? If that will cancel magnetic field out with each less, and if it will add with each more, correct?
Yeah.
So more like that lines and more near to each other. If there is less line, they are maybe far away from. Correct? So now there is a property of magnetic field lines. It always like it's not like that somewhere. Yes, so it is trying to move on the upward side because on the upward side at the top side the magnetic field lines are less, that's why it is trying to moving towards the upward side, right? So
Okay.
direction of force must be on the upward side only, correct?
Yeah.
Direction of force must be on the upward side only, right?
Yeah.
So now see magnetic field lines that we can't see now, that is our image. We can't see magnetic field lines, so it will ultimately exert force on coil. And if magnetic field lines exert force on coil in between, then in that case moving, coil starts rotating. So this is basically the principle of DC motor. You have that energy, the mechanical energy.
Okay.
Understood? Next is the types. Many are the types. Types is handbook. So first type is it can be separately excited and It can be DC motor, it can be the shunt motor, can be compound. Okay, the DC separately excited motors, we have separate supply. Like there is a field winding. Field winding means uh, basically will magnet, temporary magnet. Okay, is the construct, like as I told you, we always need magnet, right? So can we use temporary magnet for that? Hmm? For this topic, you must know construction. Okay, so as I told
Okay.
that in every magnet, right? So we
Yeah.
can use permanent magnet or we can, correct? Temporary
Yeah.
magnet is just like a solenoid only. Like we'll take a material and iron bar material and we'll wound on it and give supply, right? Then in
Yeah.
that case, iron bar give as a magnet. Give supply, then it's here and south pole over here, right? So in this case, again magnet is here. Take a shape like this of iron bar. Okay, then with the winding, make it as a magnet. Okay,
Okay.
understood? North south, north south. Clear?
Yeah. Yeah.
Now another thing, the coil. Correct? We can take circular coil or we can take rectangular, right?
Yeah.
Now instead of taking circular coil, we take coil like shape is like this, so that in place we'll put the
Okay.
case coil. We called it as coil, basically called it as a armature. In our language, it's coil, but technically armature. This is full full shoe, shapes like shoe. Okay, that's why we called it as full shoe. Clear?
And what are the lines
These
around
are
the?
the lines get iron as a magnet and technically as field winding. I told solenoid lines are okay,
Yeah.
make it as a magnet. That is known as
Okay.
winding wire, make it as a magnetic field. Magnetic.
Okay.
Now this is rotor or we can say armature. In they are having slots. The called it as a slots, and in slot have conductors. Okay,
Okay.
slots will have conductor, armature, conductor. Okay,
Can you send this
yeah,
PPT to
yeah,
me?
yeah. I'll say.
Okay.
And then in after that there is a EMF induction, and there is a rule that EMF will always in AC. Okay,
Okay.
according to Faraday's law, he says that EMF will, right, but that EMF is always in AC. But we are studying about DC, sir, right? So we
Yeah.
want output in AC, not
Yeah.
in AC, but we are getting AC because of electromagnetic. So for that, we use one device as commutator. And commutator is a device that is used to convert to DC. Okay.
Okay.
So in between, we'll use commutator. I'll send that. is a commutator, and in between we have shaft. Back to rotor, this is the winding. Sorry, back to types of separately extended. This is winding, and main part we are using armature. Correct? Part we are using, that is armature. One as a armature. Okay,
Yeah.
positive F, then armature current IA. Next one is after winding, make the armature in, okay. Series है तो field winding and armature is connected in series. Shunt means parallel. That means winding and armature are connected parallel with. Okay. Here also plus minus current is. Here also plus minus current is I and I. Okay.
What do I have to remember in this? Like the diagram. Okay.
I'll send you, but that is very diagram.
Okay.
Next is compound. Compound is divided in category. One is arm, long, shunt. Another one is short shunt. Short shunt have armature. Then the armature, the winding, and then the whole winding. Just check your handbook. Get the no,
Yeah, ma'am. I'll check it.
that these type of motors also handbook diagram.
Yeah. Okay.
Okay,
Yeah.
are the types of,
Ma'am,
like in the paper they'll ask you how does induction starts or what is on which well it operates. Okay, so induction motor basically divided into parts. One, I'm telling you about the three because the three. Okay,
okay. Yeah.
the three machine induction machine have only parts. One, the stator, and another one is the rotor is the rotating part, like you that in a have some right. So you have rotor, and outer one is the stator, that is got it.
And could you repeat
Yeah,
this
in
part?
every machine you have two parts, rotor and another one. Rotor is the part heavy. Let's take an hand blend washing machine. Inner side of the washing machine and outer side is not rotating now,
Yeah.
that is stator. That means the stationary part. Okay,
Okay. Yeah.
so this stator and this stator we are connecting time is okay,
Okay.
and then after that uh, it produce combines the rating magnetic RMF is generate. Okay,
Yeah.
how, see, first there is a R wire, suppose, then we'll have yellow wire, have wire. Okay, there is a current in the R wire first, then yellow wire, then blue wire. If there is a current, then that in that case magnetic field here, yes or
Yeah.
no? So here first magnetic field here, then magnetic field here, then magnetic field. Correct?
Yeah.
Basically, there is a rotating magnetic field. It is as rotating magnetic. Okay,
Okay. Yeah.
magnetic field rotating, and the rotor is stationary. Correct?
Yeah.
If there is a magnetic field around the rotor or the wire, then in that case, EMF And
Okay.
if EMF is, then in that case current starts flowing, right?
Yeah.
If there is a current, then in that case magnetic. Now in the stator also you are having magnetic, the rotor also you have magnetic interact with each other, correct?
Yeah.
Then after interacting, who will rotate, rotor or the stator?
Rotor.
You have given electrical energy, but you will get magnetic, sorry, mechanical energy.
Got
Got
it,
it?
ma'am. Yeah.
Understood?
Yeah.
So for this module, the theory part is complete. Okay. Till
Okay.
DC stepper motor, I'll provide notes yearly comes. Okay.
For theory, the notes, like only the